You're given an array of integers, temperatures, right? Where each element, temperatures I, represents the daily temperatures on the ith day. So 30 is the temperature on the I equals 0 day, and 38 is the temperature on day 1, and then day 2, 3, 4, 5, etc. Right? And then we have to return an output where result I is the number of days after the ith day before a warmer temperature appears on a future day. So this number 1 represents that the next warm day from this day is 1 day away, right? Because the next closest warm day is 38, which is like right next door. Then similarly, this one has a 4 in it because the next warm day after 38 is like 4 tiles apart. We go 1, 2, 3, 4, and then we land at 40, which is why it's 4. And the 0 just means that you couldn't find a day that's warmer than it, right? Because after 40, we only got 28, and well, yeah, that's the end basically. So how do we go about solving this? Let's start with the brute force, man. So what would you do in the brute force? You do a for loop, and then you go, for this element, I'm going to scan the rest of the array. And then when I find a day that's greater than 30, I'm going to take the difference between the index, right? So let's say here we have I equals 0, and then we start at j equals 1. We find that at j equals 1, we have 38, which is larger. So then we can fill up our array with 1 here for the first index, and then we move to I equals 1, and then we go, okay, then j is 2. Is this hotter? Nope. Then we move to j equals 3. Is this hotter than 38? Nope. Then we move to j equals 4. Is this hotter than 38? Nope. Then we go to j equals 5. Is this hotter than 38? It is. And then we return 5 minus 1. So it's 4 days apart. And then we kind of continue that until we do the entire list. So we move I here, j here. This is hotter, 1 tile apart. You get 1, so on and so forth. And this is going to be of O of n square solution. Not ideal, obviously. So let's try to think of a better solution. Okay then, so why don't we do something like this? I'm going to write a for loop as usual, and then we're going to start at this index. But before that, I am going to set up our results array. So the results array is going to be as large as our input array, right? I'm going to call this temperatures, and then I'll call this result, and we need 7 slots. So obviously this is going to correspond to their own respective indexes. So first up, 30. What is the next closest warmest day? So we know it's 38, but at this point the computer doesn't really know that yet, right? So that's okay. We can move to the next index. We have to remember that we haven't processed this yet. So we'll leave it there, and then we move on, and then we'll say, hey, 38, right? We know that 38 is hotter than 30. So because of that, we found the next hottest day. So we can fill this up with 1. But wait, hold on. How do we fill this up with 1? How does this actually work? We have to know the index of all the elements we haven't processed yet. And then we also need the index of I. So we know that we haven't processed 30, and the index of 30 is 0, and the index of 38 is 1. So that's why we can do 1 minus 0, which will give us 1. It's a pretty trivial example, but this is pretty important. So because we have to remember the index of all the elements we haven't processed yet, I'm going to have that saved into an array. I'm going to call that unprocessed, and then I'm going to say 0, right? After we fill up the result at I equals 0, this means that we've successfully processed this element, right? So we can pop the 0 off the unprocessed array. But then we have to add 38 in. So I'm going to add the index of 38 because, well, we haven't processed it yet. And then I'm going to move I over here. Now that we've arrived here, we ask the question, is 30 bigger than whatever element is at index 1, which is 38? Obviously, 30 is not bigger than 38, which means that it's not a warmer day. Well, then what do we do? Well, obviously, we can't put the number 1 here. And as we know, the correct answer is actually 4. Because the next warmer day for I equals 1 is at I equals 5 over here, right? So we haven't found the next warmest day at this point in time. So unfortunately, we can't really pop this thing. So we'll just leave it be for now. And then we have to put the index 2 here into the unprocessed until we find the next warmest day. And then next number, we're going to move I here as well. Also, these arrows just indicate like which elements have not been processed yet. Now we get a 36. We ask the question, is 36 hotter than this thing that we haven't processed yet? Well, luckily it's hotter, right? So we're able to fill up the result at I equals 2, which is this thing. So how many days away is the next warm day from index 2? Well, since I is at 3, we know that the next warmest day is 3 minus 2, right? Will give us 1. Then we can fill this up 1, right? And then once that's done, we have to pop the number 2 because we've processed that. And then we add the index 3 in here to our unprocessed. Moving on to 35, 35 is not hotter than 36. So because 35 is not hotter than 36, then as usual, we can't fill out the result at the index, right? I'm just going to simply put the index 4, which is here, into our unprocessed. Now notice that I don't even bother checking 35 with 38 because if the temperature at index 4 is already smaller than this one, then it's definitely smaller than every element that came before it. So back to this, we add 4 into the list and move on. And then we move on to here, I equals 40. Ooh, 40 is good. 40 is going to be bigger than 35, 36, and 38, right? So then we check I equals 5 with the value at index 4, which is 35. Is 40 bigger than 35? The answer is yes. Then we can fill out the I equals 4, 0, 1, 2, 3, 4. This one, we can fill it up with the distance. So 5 minus 4 gives us 1. And then we pop this because we've processed it. We found the next hottest day. Same story here. We do the same check. Is 40 hotter than whatever's in index 3, which is 36? Well, the answer is yes. Since it's hotter, then we can fill this up with the value 5 minus 3, which will be 2. And then we pop this and do it one more time. Is 40 warmer than whatever's in index 1, which is 38? 40 is warmer than 38. Cool. So we can fill this up with 5 minus 1, 4. And then we pop this because we've processed it. Right. So then we add 5 into our unprocessed list, and then we move on and search for a warmer day. Now at 28, we know that 28 is definitely not warmer than 40. So we're just going to add that to our unprocessed. And then we've reached the end. So for stuff at indices 5 and 6, there's actually no warmer days after. We just fill up the rest of it with 0, right? So we leave the result at those indexes with their default value, which is 0. And we notice unprocessed is basically a stack that keeps track of the indexes. So this is a stack problem. And that's all we need to know to code this basically. So let's get to it. So first of all, we're going to need our result array, which is just going to be all zeros multiplied by the length of temperature, because we want that default value of 0 for if we can't find the next warmer day, right? And after that, we're going to have a list called unprocessed, which is just empty right now. And this is where we're going to be storing all the unprocessed indices. So first of all, we have to write a for loop for I in range, length of temperatures. And then the next thing we're going to do is that, well, the unprocessed stack has elements and the temperature at I is hotter than the temperature at the top of the unprocessed stack, unprocessed minus 1. So basically, because unprocessed is keeping track of indexes, of tracks, indices of temperature array, we're going to use that to access the temperature at that day, right? So once we found a warmer day, then we can write into the result list. So result at unprocessed minus 1 is equal to, well, the difference in the indexes. Pretty simple. And then once we've written to the result, it means that we've processed that day and we can safely pop it. So after doing all the popping, then we just append the index of the current day into unprocessed. And then we return result. Oh, sorry, I think there's a typo. Yeah, and that's about it. Okay, just real quick, I want to talk about the time and space complexity that we have going on here. So for the time complexity, we have a for loop here that goes through every index of temperatures, right? And then for each day, we're going to process it once by adding it to the stack. And then we're going to process it one more time when we pop it from the stack. So every element is going to be processed at most twice. So with that, I can say that the time complexity is O of 2n, which simplifies to O of n. And for the space complexity, well, we have the result array, which is going to be the size of the input array temperatures. And then we also have the unprocessed, which is a stack. And in the worst case, if we have an input of like, let's say like 22, 2120, where each day is successively colder than the last, this popping while loop is never going to happen. So we're just going to keep appending it over and over again into our stack. And in the end, the stack is also going to be the same size as the input. So I'll say that the space complexity is O of n from the result array plus another O of n from the unprocessed stack, which simplifies down to O of n. Okay, bye.